In the study of electromagnetism, you have studied Lorentz force. Okay, I know this thing. So, Lorentz force is known to you, but here I am going to make this video for Lorentz about Lorentz force, which is applicable for normal speeds as well as for relativistic speeds. Yes, the form means mathematical expression which is known to you for Lorentz force, that is applicable only for normal speeds or normal velocities of charged particles. Means those velocities of charged particles are not comparable to the speed of the light. You know, speed is having the maximum maximum velocity, okay, and it is 3 into 10 to the power 8 meter per second. Anyway, I am not going to discuss all those things here. What is the mathematical expression for Lorentz force? You know that when a charged particle, whether positively charged or negatively charged, when a charged particle moves through an electric field as well as in the presence of magnetic field, means the charged particle is moving through electromagnetic field. Electromagnetic field means presence of electric field as well as magnetic field is there. Okay, maybe in your special case electric field is absent, only magnetic field is there. Maybe in your special case magnetic field is absent, only electric field is there. And again, the normal case is both are present. Okay, for all these things, for all these conditions, Lorentz force is applicable. And one more thing, Lorentz force is not a new force, new type of force. Lorentz force is not a new type of force. Name is given, okay. This is a special name given to this. And whenever we are using this term Lorentz force, that means we are dealing with electromagnetism. We can easily understand. Okay? But this is not a new kind of force. This is just the vector summation of the forces of forces due to electric field, due to the presence of electric field, and forces due to the presence of magnetic field. Anyway, what is the mathematical expression for Lorentz force? If Lorentz force is denoted by F, then I am writing here, you can see, this is Lorentz force. F represents Lorentz force. This is equal to Q into E plus V cross B. Okay. This is the expression for Lorentz force for normal speeds or normal velocities of the charged particle. Here F is the Lorentz force, small q, this represents the charge of the charged particle, means electric charge of the charged particle. Okay, whether it is positively charged or negatively charged, for both the things it is applicable. E is the electric field, capital E, electric field. V is the velocity vector. Okay, all these things are vectors. Q is not a vector, it is a scalar quantity, but other things are vectors. V is the velocity vector and B is the magnetic field. Magnetic field is a vector quantity. Electric field, this is also a vector quantity. So this is the mathematical expression for Lorentz force for normal speeds. But when the speeds become comparable to the speed of the light, means if the velocities of the charged particles become comparable to the speed of light, that means if the velocities of the charged particle approach the speed of light, in that case you have to take account, means you have to consider the relativistic effects also, because in case of relativistic speeds, the normal concepts of or classical concepts of motion and forces break down. At relativistic speeds, there is a distortion of space and time. Means the effect of time dilation and the length contraction you have to consider in case of relativistic speeds, and this was given by Einstein. Name of Maxwell is, name of Maxwell. He is related to the theory of electromagnetism, and name of Einstein, he is related to the theory of special relativity. Okay, so we have to change this expression for Lorentz force when we are considering relativistic speeds. When we are dealing with normal speeds, is there any effect of relativistic speeds? Yes. In case of normal speeds also, there is effect of relativistic speeds, but that effect is negligible as compared to this expression. Means values obtained using this expression. If you compare these two, okay. So, relativistic effects become negligibly small, and that's why that effect is neglected. So, to account for relativistic speeds, okay, in the case of Lorentz force, we have to add more terms, and those terms are, so plus sign, then again write this Q, then here will appear V by C. Here V is the velocity, C is the speed of light. Here V is, I have not used this arrow sign, okay. That means this is only the magnitude. Only the magnitude. This is not a vector. Okay. Multiplied by this expression. Okay. Let me write using this bracket here. Okay. Then it will be easier for you to understand. Okay. Same expression. Okay. Just copy from here to here. Okay. And copy and paste, okay, and this, okay. So this V by C, this is multiplied with this expression. Here V is the magnitude of velocity of the charged particle, C is the speed of light. So whenever you are doing this thing, that means you are considering the relativistic effect also. Okay. For all the cases, the total expression, the entire expression can be used, and you can easily see that this V by C term is there. So if V is very, very small as compared to C, then this becomes very, very less than 1, then this expression, the lower one, okay, this expression becomes negligibly small as compared to this one. Okay, so for relativistic speeds, this is the total expression for Lorentz force. So this was all about Lorentz force, both for normal speeds as well as for relativistic speeds. Okay. Anyway, so this is the end of this video. Thank you for watching this video.